Hello. Now we will study the electrostatics of a conductor. So till now we were studying the this insulated bodies where the electrons, free electrons were not there. Now we will talk about the conductor, and since we know the difference in conductor and insulator is the number of free electrons. Number of free electrons in case of conductor is approximately, you can say, they are infinite. There is no dearth of free electron in case of conductor. So this is our conductor. This is a conducting body. So there are a lot of free electrons which will be inside. Number of free electrons will be there. Okay, I'm showing 4. And we want to study the electrostatics of the conductor. So first we'll start with properties. There are several properties of the conductor. The first property we want to study regarding the conductor is the electric field. Meaning we want to see how the electric field, how much is the electric field, how much will be the electric field inside the conductor. So electric field we want to calculate, and that too inside the conductor. So as you all know, the electric field inside the conductor in static condition always remains 0. So static condition means is equilibrium, meaning in equilibrium, whenever you will be seeing equilibrium, in equilibrium electric field inside the conductor will be 0 always. Now why is that? So to prove that electric field inside the conductor will be 0, let's assume that there is an electric field inside because of any reason. So I'm saying there is an electric field, non-zero electric field inside the conductor. And as we know, this conductor, it has lot of free electrons. Free electrons are the charged particles. So this conductor is having lot of free electrons. The moment electric field will come inside the conductor, the moment this electric field will come inside the conductor, these free electrons, they will experience a force due to this electric field. So I'm assuming, let's say there is an electric field inside the conductor. The moment electric field is coming inside the conductor, because of this electric field, since this conductor is having lot of charges, those lot of charges will experience the electrostatic field, electrostatic force. And that electrostatic force obviously will be opposite to the direction of existing electric field. So due to this electric field, non-zero electric field, these electrons, they will start moving. And since these electrons will start moving, the redistribution of charge will be happening. So I cannot say this is the equilibrium condition. So if there is a non-zero force, the equilibrium condition is not there. If there is a non-zero electric field, the equilibrium condition is not there, because of non-zero electric field, there will be a non-zero force onto the electron, and due to that force, these electrons will keep moving. And they will keep moving till they will experience the force. So each and every electron till each and every electron is experiencing a non-zero force. Till each and every electron is experiencing a non-zero force, that electron will keep moving. Because if the force acting onto the electron is non-zero, then from the second law you can see, if the force is non-zero, net external force acting onto the particle, in this case it is an electron, is non-zero, then that electron will experience acceleration. And because of that acceleration, if that's the case, it will keep moving. Its velocity will not be 0. So all these free electrons, they will keep moving till they will experience this non-zero force. They'll keep moving. If there will be equilibrium, if these electrons will ever achieve equilibrium, it will be only one case, because equilibrium means each and every electron will be having velocity 0. And if each and every electron is going to have the velocity 0, for each and every electron the acceleration should be 0. And if each and every electron is going to have the acceleration 0, it means for each and every electron the force should be 0. And if each and every electron is going to experience the 0 force, that electron, this force experienced by the electron, it's nothing but Q into E. Since Fe is nothing but charge onto the electron, that we define as E, multiplied with external field. So you see, the charge onto the electron, it can never be 0. So if ever force onto the electron will become 0, and that will happen when these electron or the system will achieve the equilibrium. If ever the force acting onto the electron will become 0, that will happen only under one case, and that case is electric field, when the electric field will become 0. So ultimately, if I'm saying the electric field inside the conductor is 0, there is a condition. And that condition is when the conductor achieves the equilibrium. Equilibrium means after a long time when the electron will settle themselves in such a position so that the net force experienced by them will become 0. And at that point of time, at each and every point, the field, net field at each and every point will be 0. And when I'm saying net field, I don't mean the field created by the outside, the field created by the inside also. So there may be, at any point you want to see, there will be two types of electric field. One field which might come from the outside, and one field which will be generated by these spatial distribution of these electrons. They will distribute themselves. And because of that, at each and every point, net field has to become 0. And when that will happen, the equilibrium will be achieved. That's the property. So whenever you deal with any conductor, and if you place that conductor in any external electric field, if I'm having a conductor, and it's a neutral conductor. If I place this conductor in an external electric field, let's say this is the electric field, external electric field. If I place this conductor in an external electric field, then because of this external electric field, the electron inside the conductor, they will start experiencing a non-zero force. These electrons which are inside, they will start experiencing the non-zero force. This is not the equilibrium. When they will experience the non-zero force, they will start moving. They will start rearranging themselves. And finally, when they will achieve the equilibrium state, at that time they will be having the electron in the conductor. They will not be randomly distributed. They will be distributed in a pattern. So some of the electron at some points will find this positive charge, and some point you will find the negative charge. And due to the redistribution of charges inside the conductor, obviously, this redistribution of charge will generate its own electric field. I'm calling that field as E That's the field which is generated by the inside charges. So at any point when you will see the net field at equilibrium, which is the combination of external field and internal field, at equilibrium that will become 0. So what happens whenever you place this conductor in an external field? The electron, they rearrange themselves. And due to that rearrangement, each and every point, net field will become 0. And that will happen when the the electric field generated by the internal distribution of the electron will be exactly opposite to the field at each and every point due to the external sources. So at each and every point, whatever is the field, let's say external field is in this direction. At this point, external field is in this direction. Then this distribution will be happening in such a manner so that at this point, due to the internal distribution, the electric field should be exactly opposite to that, exactly opposite. And if at this point, some other point, let's say, at this point, you find the external field in this direction, it can be any kind of distribution, then due to the redistribution at the same point, field will be in exactly opposite. So see, it's not that simple redistribution which will be happening. At equilibrium, redistribution of electron will be such that at each and every point, that redistribution will be making the net electric field 0 by having its own electric field exactly opposite and equal in magnitude to the external electric field. And that's the physics behind this conductor. So whenever you place a conductor, whenever you have a conductor at equilibrium, that conductor cannot have a non-zero electric field inside the conductor. And when I'm saying inside the conductor, I'm talking about each and every region where the free electrons are available. Meaning ultimately this field is being made 0 because of the redistribution of the electron. So electrons has to be there. If electrons are there, the field will become 0. Okay, so that's your first property. Okay, thank you.